The first question that everybody should have in the mind before starting any work is why to do that work. If you answer the why part for you, I think then everything follows from there. So, for example, if I ask you, why do we eat? You have the purpose. The first thing is you want to live, that's why you eat. The second thing is that maybe you get some amusement after eating, so that's why you want to eat. Now, your why part is clear. If your why part is clear, then you are going to eat. For example, it's really hard to feed the small kids. Why? Because they don't know the answer of why part. So why are they feeding us? Okay. So once you get accustomed to eating and stuff, so then it's easy for the people to understand to understand why do we do a certain thing. The first thing that I would like to address is why DSA. Okay. Why data structure and algorithms? So why do we study them even? I'd like to rather give a answer in a detailed manner so that you again have that thing addressed so that you don't have this question in the head, why are we doing it? It's not for the job only, okay? And it is for the job per se because you are going to be making a career in your career in tech, so there you will have a requirement of this. But why DSA? It has a broader answer than this. The first thing I would like to say is problem solving. Problem solving. So how many of you like the riddles, for example, when you were kids and then you were asked riddles, something like if you have three glasses and they have a different measurement, and if you want to, for example, measure a certain amount of water from this, and you sort of put your brain and you enjoy this process of finding the answer. Okay, and even the whole point of this is to get you accustomed to solve problems in the real world. Okay, that's what DSA does. So what, as a computer scientist, as a computer student, so when you'll be software engineers, probably researching, whatever you will become in the careers, you will have to solve real world problems. For example, take Amazon. So Amazon actually is solving a problem that is, it is delivering the food items or maybe the items that you are using for daily use via some online interface, and it is a real world problem that existed. Okay, so after, even if you see any type of thing that the computer science people do, that is basically solving a real world problem. So to solve that real world problem, you should have in the head how to solve the problem. So in the first step of the problem is understanding the problem. Do not treat it as a lecture, please. I feel it like a lecture again, and you should not treat it as a lecture because I just want you guys to get the feel why are we doing this. So I'm sort of giving you the why part so that you do not ask yourself, oh, I should not be doing this. I don't like it at all. So everything that we do in computer science is practical mostly, and then we're solving the problems. The first step I said is understand the problem. Okay, so if you carefully read some things and then you are looking at your environment and you see, let's talk about Jeff Bezos, for example. What did he find?
The screen is not visible actually.
Is it not visible? Oh, I see. Okay, so this is the first thing I want. There are a lot of technical glitches. Okay, I hope now it's visible. Is it?
Yes, sir.
Nice. So I was talking about why DSA. Why should we even care about DSA? So I told you, being a computer science students, we usually solve the real world problems, and that's what DSA gives you. The first thing that DSA gives you, it sort of ingrains into your head how to solve a problem. So I said there's a process to follow when you are solving a problem. The first part is understanding the problem. Okay, that's the first step in solving any problem, is to fully understand it and what are the needs to accomplish. Okay, what are the outputs that I need to gain, or what are the things that I require before solving the problem. Okay, so this step basically involves carefully reading and analyzing the problem statement and the problem around you. If you ask me what made Jeff Bezos a billionaire, because he actually found a problem, and most of the students, they have been teaching from me this machine learning, artificial intelligence and things, so I always focus, it's really easy to come up with the solutions. The hard part is to come up with a problem. Okay, if you come up with a really good problem, you find some really good problem to solve, then it will be easy for you to find a solution. So Jeff Bezos, why is he a billionaire? Because he solved a $1 billion problem. So what is the problem? Because everybody had to hassle to the markets and they had to get their goods, and then they had to look at a lot of stuff, and after carefully analyzing the things, then they took it back to the home. But if you see now in online, what do? We'll first see the items, and then afterwards we check the reviews and see the features and stuff like that, and we'll come to a decision without even moving from a place. So if you see, this shopping was a $1 billion problem. Jeff Bezos solved this $1 billion problem and he became a billionaire. That's what I'm saying. If in order to solve any problem, the first step is to understand the problem. Okay. Then if you see in the computer science realm, now you have to use computers to solve this problem. Okay. The second thing is, you have to choose now right data structures. You have to choose right data structures. So what is the data structure? We'll have a detailed discussion on these things. There are something where we keep the data, where we assess the data, and stuff like that. So if you choose a right data structure, which stores and organizes data in a specific way, that's what data structure is. Data structure is stores data and organizes in a specific way, and then we have to select that right data structure so that when we retrieve the data, or when we do some operation manipulation of the data, so it should be stored in the right data structure so that our algorithm becomes easy. Okay. Now you have to know the data structures. Okay, now you fully understood the problem. If you understood the problem, oh, this is the problem that we are going to solve. The second part is that if I have to model it in the computer, and then I have to use computer from solving this problem, then you should be able to know what data structure to use. Okay, how to organize, how to store the data, and for that purpose you must know data structures. Okay, linked list, arrays, hash tables, and stuff like that. Then after that, now you have the right reason. Now you have to choose an algorithm. So you have to select and right algorithm. Select the right algorithm. Okay. So if you are selecting the right algorithm, and what is the meaning of right algorithm is that we'll look, and what this right algorithm means, maybe it has something to do with space and something to do with time, how fast is the algorithm, how space efficient it is, and things like that. Okay. And we'll also formally define what an algorithm is. It is a stepwise procedure for solving a problem. Okay. We can have a lot of algorithms to solve a problem. Okay. But which of them is, I'd say, efficient in terms of time and space. So for that, we also need to know what algorithms are. Okay. And then afterwards comes the implementation. Okay. After this, we have to implement the algorithm. So now you know the why part, because problem solving, like, if anybody tells you why are you doing DSA, because we have to solve real world problems. For that, if I even understood the problem, the second part comes in. Now I have to implement the solution. I have to use computer to do the thing. For that, I need to choose right data structures. Okay. I need to choose the right algorithm to follow this, and then afterwards, and then it's an iterative cycle. You will implement the algorithm, you will test and debug it, and then you will again keep on improving it. Probably you will keep on optimizing the solution. You will optimize the solution, and then you will continuously iterate and refine. That is, so these two parts are sort of fixed. When you are fixed with this, and maybe you can even change these, then you implement it, test, debug, optimize, again go back, find some really good ways, again implement, test, debug, optimize the solution again, and you try. This is an iterative process. Now this is the iterative process. You keep on doing it, and that's why you see version control of these applications and stuff like that. Okay. And the more important part than problem solving, I'll say, it's a common language. So now if you are going to make a career in tech, and if you have to go into the tech industry, so there you will have to speak a language. So this data structure and algorithms, particularly in computer science, serves as a common language. So for example, when you say an array, you must know an array. Okay. When you speak about stacks, you must know what is a stack. So these sort of words, you must know what is the meaning behind them. So it serves as a common language between the developers when you talk to each other. Okay, when you talk about a specific solution. So there, the assumption is that you know all of this stuff. Okay, this serves as a common language. This is one of the why parts. Why should you even learn this? So I assume that all of you want career in technology, and you want to do something with computers. That's why I'm giving the why answer according to that. Okay. Now you have common language to speak with the other folks that you are working with. Okay. Then the second thing is, it's the I think third thing is, it builds the foundation. So it's a foundational topic. It builds your foundation so that if you have to do something advanced, now you are interested in, let's suppose, operating systems. Okay. Now you know a language and you know rest algorithms, and if you want to understand the machinery mechanism of how operating system work, and that time you can just use these foundational skills that you learned, and then maybe on them build these skills of operating system. What is the memory? Okay, how does it work? What is the kernel, and what is the process? Okay, and what are these scheduling algorithms and things like that? You must have a foundation to understand these things. And even if you now want to learn about, let's suppose you want to implement some computer network protocol, for that you must know DSA algorithms. Okay, and then again, you also, if you have to read some advanced topics other than these subject topics, and then you want to, for example, pursue physics, and you want to use computers in physics. So if you have a real good foundational knowledge of this, then you can easily translate your skills into the into this physics, maybe chemistry and stuff like that. Okay, and the other thing I'll say is it will build algorithmic thinking. Okay, so this is a huge topic. All of these will take at least an hour or so to explain algorithmic thinking. So what is this? Because right now, every person is thinking in their own realm. For example, if I talk to you about this pen, what is this pen? Each but people, everyone will have an answer according to him. So there is actually a quote that if you have a hammer in your hand, everything looks like nail. So what is the, like, again, I'll reiterate this. Just listen to me. What this quote says. It says that if you have a hammer in hand, everything looks like nail. Suppose you have a hammer. So if you look around here, you want to just hammer something, and you feel that everything is a nail. That means the view of the world that you have, it is based on the knowledge that you have in your head. Okay, so let's suppose if somebody is a carpenter, if he walks into a room, so what will he see? He'll just have a look at these doors, windows, because that is the knowledge he has in that, and he'll see the delicacies and the intricacies, details of these doors, windows, and stuff like that. Okay, and if some plumber comes in, and he will see these walls and stuff like that. If generally like this happens, maybe when I go somewhere and I see tech devices, because that is the knowledge I have in my head. I see, oh, there's a really fast GPU. Okay, there's a good cluster, supercomputer, something like this. So I'm interested in this stuff because that is the knowledge I have in my head. Based on the knowledge, people perceive things differently. That's where this algorithmic thinking comes. So if you have to solve a problem, so many people think in different ways. Okay, I think it was a quote from, I don't know, if Bill Gates or Steve Jobs, I don't remember exactly. So he said, I wish every person in the world knows how to program. Why? Because it teaches people how to think. Now, if I tell you, okay, 1 plus 1 is 2, can you have an algorithm, or can you make computer understand this 1 plus 1 is 2? You have to go to the nitty details, to nuts and bolts, so you understand yourself. For example, and I usually say this: understanding is not equal to knowledge. Okay, so understanding is not equal to knowledge, or knowledge is not equal to understanding. So if somebody has a knowledge of something, it doesn't mean he understands the thing. Okay, so for example, you have a knowledge how to swim. Okay, so if in order to teach somebody swimming, okay, you will maybe say, I do this and that movements, but the guy has to go into the swimming pool, or he has to go into some water stream, so that he learns the swimming himself. So the level of understanding is different, and the knowledge is something different. You can memorize something, that's again a type of knowledge, but having an in-depth understanding is something else. That's why this algorithmic thinking I'm talking about. So if you are finding a real world problem, you must know how I can make the computer do this, and how I can teach the computer to, in order to solve the problem. That's where this algorithmic thinking comes. You must think algorithmically. It should not be thinking like, you must not think like, I'll have to teach a human, I'll have to ask human to do this. Because if you ask a human, you just use natural language. And now we are at the at least in the domain of AI, we can now instruct machines in terms of this just natural language, and then they give the answers according to that. But still, we are way far behind where we can give the instructions in and natural language processing for the natural language in the to the machines, and these machines will answer. That's why you must have an algorithmic thinking for this. Okay, and then the best part comes in where you said that it is helpful for the interviews. That's why even companies, they do ask questions about this, because they want to check this. They want to see if this guy is able to handle a problem, if he has the common language, if he has the foundations, does he know how to think algorithmically. Okay, and these are the question. Maybe you won't be, and most of the things, when I tell people that this DSA is important, they say, sir, I have been working with in the company, but I have not used this DSA. I think 80% of times I never use it. Maybe sometimes I here and there use it, but most of the times I have never used this. It's not about the usage, it's about the development of your thinking. For example, you play cricket in your childhood. You do not learn the cricket only. You learn a lot of skills. For example, you learn how to run, and you probably learn how to move in a certain way. Okay, you learn a lot of skills that are translated and they are transferred when you do some other activities in the day-to-day life. Okay, that's the same with education. When you do something, it is not that you will use it immediately, but some parts and some portions you will use it here and there. Okay, is the why part clear at least? Like, I couldn't do the justice with the why part, but I hope that everybody agrees with me on this part. Like, is everybody on the same page on
Yes,
this?
sir.
And would you like to argue with me? I'm open to arguments. Okay. Again, to reiterate for the people, for the folks who joined a little bit later. So I said that if you know why to do a thing, you'll easily do it. I gave an example of eating. You know why to eat. But that's an evolutionary biology. I don't want to go into that. So there's an argument in evolution that whatever increase the chance of survival, you urge that. Okay. For example, eating it increase the chances of survival for human beings. That's why they eat. Okay. That's what it's ingrained into our head, and it is like it has been ingrained by the evolution because that's how we survived on this planet, and that's why these animals have this instinct. They have instinct of living because they are so bewildered. If you see like cat, if you just throw something at the cat, they'll run away. Why? Because of that instinct of survival they have. That's why I'm saying if you answer the why part for you for anything that you want to do in the world, maybe it's some like nonsense thing that people will say this is nonsense. But if you have understood this why, okay, if you some sort of explain the why to you, maybe after that the task becomes really easy. That's what I was answering. I was answering why DSA. The first thing that I said is problem solving, and then we said that you have to choose right data structures, right algorithms, and then implement it, test and debug, optimize it. Okay. For this you must know data structures. For this you must know algorithms. Okay. Then for here you must know a language to talk to computer. Then you must debug, optimize, and keep on doing this. Okay. And the second thing I told is it's a common language because most of you are going to make a career in technology and you'll have to talk with the peer developers or the people who understand the tech, and you will have to speak that their lingo. So their lingo is stacks, trees, data structures, and these greedy algorithms and stuff like that. So if you sort of speak their language, it'll be easy to communicate. Then it builds the foundation. So whenever you're doing something advanced in the computer sciences, so we assume that you know these foundations. You know data structure and you know algorithms. And if you want to pursue anything, even I was giving an example of physics or even chemistry. People code a lot in physics, chemistry nowadays. If they don't have these foundations, they'll have to go to the foundations. Even we've got some people who are not from the computer science background, but still they won't learn it. Why? Because it's used in their fields. The most important thing, and I have been like listening to this when even my professor was teaching me. His name was Pandurangan. He's the one who brought IITs into India. So he has been teaching from 40 years. So the first statement he said is this algorithmic thinking. He was always like, we made a meme about this algorithmic thinking, computational thinking, and mathematical thinking. So he was constantly telling us these things. So you should think algorithmically. Then after a while, after I heard it a lot, then I got to know, oh, this is what he meant by algorithmic thinking. So because people think in a certain way. Okay, if you think in terms of computers, if you think in terms of algorithms, and then you will really feel, oh, what's the meaning of algorithmic thinking? It's not I have to teach a kid. It means that I have to teach a computer, and I must go into the that realm of computer so that I can make it understand. It's not that I have to teach a human being. Okay, this is what it is. I have to make a computer understand. That's what I give an example. If you want to add by using computers, so we build something called as half adders, full adders. So if you have no knowledge, like of even if I ask you how is 1 plus 1 is equal to, maybe most of the folks won't be able to answer. They'll give me some philosophical argument. Maybe they'll just give me some shapes. Say, this is one, this is one, this is why if you take these two and this becomes two. Okay, but if you go on the bare bone basic logic and you will see what is the meaning of 1 plus 1. Okay, that's why you have to go under these like bare bone basics and open these nuts and bolts and try to understand the things from first principles. And that's obviously the other thing that I said it's really important for interviews. And even when I take interviews, I ask questions on this algorithms because I want to check all of these stuff. And we have to filter candidates obviously. So if you have to filter candidates, so there is no better tool than asking them data structure and algorithms. Is everybody on the same page?
Yes, sir.
I see. Can you just show me a thumbs up if you are listening? Are you bored? Am I giving you some sleeping gas and you probably are slept? Nice. Okay. The buzzword that the YouTube community is using is this roadmaps of this. Again, leveraging the term. So I'll say a roadmap or the outline that I'll be using. to teach you these data science algorithms. So the first thing that I would like is programming fundamentals. This I'll assume you know it. Okay. My program fundamentals, the definition of my program fundamentals is a little bit different. People usually will tell you learn C, learn C++, learn Python. It's okay. I won't like to argue, but the thing is, programming fundamentals is something different. So it is that programming thinking. Okay, I want you to know about what loops are. I want you to know about what functions are. Irrespective of what language a loop is a loop. So you can write a loop in C, you can write a loop in C++, you can write a loop in Python, Pascal, COBOL, whatever the language is there. Okay? But the thing that you should know is the programming fundamentals. You should know art of programming. So you should know art of programming. So irrespective of the language that you choose. Okay. So how I will teach is I'll first explain you a concept. I'll give it what's called a pseudocode. Pseudocode means like this is not a code that you can implement directly. You'll have to choose a language. Okay. But I want you to know the programming fundamentals. What is the meaning of a loop? What is the what is the functionality of a loop? Why do we write a function? Okay, the things like that. All these basic things I would say I have covered this in the previous series of lectures that we conducted in Python. So mostly when I will be teaching you the pseudocode, then I'll code these algorithms or code these problems in Python. Okay, that will be our language of choice. But I don't care what language you use. Seriously, I don't care. But the problem thing is you must be clear with the program fundamentals. You must have that art of programming. Okay, you must be thinking in those terms how a programmer thinks. And the second thing that we'll be going is now if you know how to talk to a computer, now you have that thing with you where the computer is able to understand you. The second thing that we'd like to go is time and space complexity. Okay, so what is the meaning of time and space complexity is that now you wrote an algorithm, you want to evaluate the performance, you are seeing how good is this algorithm. Okay, there are different ways to solve a problem. If you are the people here, I'll ask you how to make a cup of tea. Yeah, you will say different methodologies and methods, and then you will evaluate. But in making cup of tea, the evaluation will be how tasty is the tea. Okay, and the taste again is a subjective term. So, but here we have an objectivity in this computer science. We have objectivity. How much time your algorithm takes? Okay, how much space does it take? If it takes less time, less space, we are good to go. That's why we must know how to compare the performance of these algorithms. Okay, how to compare performance. So I would like to write it with that. Okay. So with each I'll write a box so that you understand what is this for. So here I want to compare different algorithms, and I want to see the efficiency. Okay, I want to compare different algorithms, and I want to also evaluate the algorithms. So evaluation should be done. That there should be a tool how to evaluate these two things. Okay, if you see in your classes even, for example, we say this guy is a topper of the class. How is he a topper? Because he got 90%, and we have a metric for that. We have a physical quantity that we can measure. So here also we have something we can measure. We can measure time. We can measure space, and based on that we can evaluate an algorithm, and we can compare with different algorithms, and based on that we can optimize it. And it is also then used for the scalability. Scalability means can you use it for the real time? So if you deploy this algorithm and millions of people are using it, can you use it? For example, if you see in famous example, most of you I assume are from Kashmir. So this JK boat website, so whenever the results are here, the website is down. Why? Because it cannot handle that much of traffic. That's why that website, there is a chance we can scale it. Okay, we can make it like we can make it a website better because probably they are using something else. Not in terms of only website. I'm just giving you an example. So there are different algorithms, and different algorithms are suited for different things. And after you are done with this, now you know how to talk to a computer. You know how can you communicate with it, and you know how to evaluate a thing. Okay. Here actually there is a famous scientist. I would like to take his name. His name is Roland Luth. So he was doing this. So all of this is called like first this is called analysis of algorithm. Okay. This time and space complexity, and then how many steps. This is usually called as analysis of algorithms. Analysis of algorithms, I'll write. Analysis of algorithms means, okay, now I have constructed an algorithm, how to analyze it. What are the tools to analyze it? So he actually wrote a huge, I think 6, 7 volume book known as Art of Programming. So there you will find a whole book dedicated to only sorting. Then once you know at least two of these things, then we'll move to arrays. Okay, arrays are the basic data structures. Okay, then we'll move to arrays and we'll see what these arrays are capable of, how to store data in arrays. Okay, this is basically the really basic thing. We'll also see what are 1D, 2D, 3D arrays in this. We'll see what arrays mean, and then we'll see why do we even study about arrays. Okay, and then we'll see key what are dynamic arrays. We'll see 1D, 2D, 3D arrays, and we'll see what are dynamic arrays and stuff like that. We'll see a lot of things about arrays because these are the foundations. After we are done with arrays, so I'll first teach the theory. I'll first teach you maybe a couple of concepts of arrays, what an array is, how is it stored in the memory and stuff like that. Then we'll go on solving some problems. Okay, I'll solve some of the problems maybe with you guys and while we're taking the sessions live, and after that I'll give you some problems that you can solve on your own. Okay, and after we are done with the arrays, then we'll come to searching. There are different ways of searching. You might have heard about linear search, binary search. There are different versions of this, like linear search and binary search, how to do it. And once data is stored in a specific data structure, how to do the searching. Okay, searching is a fundamental topic because every time most of the times you're using searching. When you are calling somebody, you're just writing his name on your contact list and it searched through the whole list. Okay, that's where searching comes in. And if you see some other tasks where it is used, so you see, for example, you have to make a decision, so you search something, you search your decision, you search all of your possible spaces, and then you make a decision based on a specific thing. And for the optimization, even searching algorithms, they'll help you to optimize the things. For example, you want to reduce something and you want to reduce time and resources, you want to allocate and you want to search something. Okay, the searching is really important. From the Amazon to Netflix, you're everywhere using the searching. So that's why it is a really important topic. We'll see the real world examples there even. But the fundamental is that how to search a thing. Okay, what is binary searching? What is a linear search? That will learn about these. And the same thing is the thing will be we'll first learn about the theory, do some questions in the class, and after that you'll be given some questions to do it on your own. It's a totally flexible course because you're adults. I don't want to moral police you. I don't want to say, no, you must have to do it. It all depends on you how much you are willing to study about this and all of these things. Then we'll go about learning about strings. So strings are basically fundamental to computer science and programming. So they represent some sequence of characters. Okay. So if you have to process some text, for example, address or phone numbers even, so you use strings. Okay. There you will use strings. And then for the data representation, many other things that you use in your day-to-day life is basically string. Okay, even a programming code is a string. Whenever you are writing a code in your that's a string. You're taking input and you're giving output, and most of these things are string, and you must know how to manipulate this string. So we'll learn about string manipulation, we'll learn about pattern matching, regular expressions, a lot of things will be there. Okay, so this we'll learn about the strings. And then we'll go on to the again basic data structure, that is linked lists. Okay, so linked lists, if you know some of the limitations of arrays, so arrays are something which are constant in size. That's why I had a topic specific dynamic arrays, so we'll see that what it is. So in C++, we did not have the arrays which had dynamic structure. Then we went on the linked list. Okay, so memory allocation is dynamic in this, and then we can insert, delete, and it gives a flexible data structure for us. Okay, then you will use it a lot in traversing and stuff like that. And we'll go on linked lists. Once we are done with this arrays and links, I'll say these foundations, these two are the foundations, this arrays and the linked list. They are the real foundations from which you can build any other data structure. So if you understood these two things, then you are ready to go and write your own data structures. Okay, and after that we'll read about stacks. They are really taken from the real world. What a stack is, it is actual stack. And if you see how function call is being made, how do we evaluate expressions, even when you go on the back on the web browser, so you're browsing something and you want to go to the previous page, so internally they are using some stack maybe. Okay, and if you do undo, for example, you are typing a document and you press Control Z, so it undoes the operation that you did. They're using a stack at the background. Okay, and if you see how memory management is done, it is basically done by the stacks. Expression matching, and a lot of things that you usually do in the real time. I think most of you have done pressed a lot of buttons today, back, and you wanted to go back and run it at a different page, and internally it was using stacks. Then we have queues, and all these will use arrays and linked list to implement the stack, to implement this queue, to implement most of the things. We'll use these arrays and linked list. So then we'll go on the queues. Okay, queues basically have the same definition as we have the queues, the lines that, for example, if you are on a food counter and you want to collect your food, there you form a queue. Okay, that is whoever goes the first, he'll collect the food first. That's the concept of these queues. Then we'll go about a beautiful concept that's trees, and it's completely different from the trees that you look around you. And we have something, trees have the root node at the top. Okay, and in the real world roots are at the bottom. So we'll see that why are they even called trees. So we'll see the trees. Okay, then we'll see actually these graphs are This graph is a superset of trees. Trees is a subset of graphs. So we'll learn about graphs, and then we'll learn about hashing. Okay, hashing is a technique where you hash some values and stuff like that. Okay, once we are done with the data structures, so this part will cover data. These are basic data structures. So these arrays, linked lists, stacks, queues, trees, graphs, and hashing. So even hashing is not a data structure. We have a hash table, which we'll call it a data structure. So these are the basic data structures which you will most times use it. And then there are advanced data structures like B plus trees, B trees, red black trees, segment trees, and stuff like that. There are a lot to cover again, but you should be well versed with all of these first. Then we'll go on to the algorithmic side. What are the algorithms? Now I know how to store and retrieve data, because what a data structure is, at the end of the day, it is nothing but where you store the data and you take the data in a certain way. And then now you have to use these data structures into some algorithm. Okay, the first algorithm type we'll study is divide and conquer algorithms. Okay, we'll divide something and we'll conquer it. Okay, what British did. And there's a whole class of algorithms. There are a lot of algorithms. Binary search is a divide and conquer algorithm. Okay, then we'll again go to sorting. We'll learn about sorting algorithms. Okay, there is a huge book on sorting. I think I know, I'll say 10 plus. I know at least I know 10 plus sorting algorithms that I have even coded myself. So there are, I think, hundreds of sorting algorithms. There are something comparison based sorts, and there are non-comparison based sorts like radix sort and things like that. So bucket sorts. Even you might have heard about these bucket sorts. So there are a lot of sorting algorithms. Why is sorting used everywhere? So everywhere, whichever website you go, whichever application you use, there is sorting in one form or the other. Okay, so it is a really important topic to cover. Then we'll go on to this greedy algorithm. Okay, so what these greedy algorithms are, we'll learn about these. There are different versions of these greedy algorithms. Then most important topic where students struggle is recursions. Then we'll go on the recursions to read about recursions, how to, if we have an iterative program, can we make it a recursive program? What's the advantage of making it a recursive program? Okay, then we'll go on the backtracking, and at the end we'll close everything with dynamic programming. And if we got time, and then we'll learn about some advanced data structures. But again, I'll reiterate what will be the things we'll teach. We'll first read about a bit of theory. Okay, once we are done with the theory, and we'll directly get our hands dirty, we'll go do some hands-on, solve some problems related to that data structure, related to that algorithm. And then most of the things that you have to do, why here you come. So after that, you will have to do a lot of hard work on your own, and you get better at it. So everything that I can say you is, you have to practice a lot. So if you practice, so you'll become really good at it. Okay, after that, maybe you can start doing the projects and stuff on your own. So here, as even Amir mentioned the message, we are hoping to at least solve 200 to 300 problems, not just from the lead code, but we'll solve it from different platforms. And I'll try to find different pattern questions which people generally ask in the interviews and stuff like that, and we'll try to solve them. But the whole crux of this is not to just prepare you for the interviews, but rather to get you equipped with the problem solving skills. You should think critically, you should think algorithmically. So if somebody asks you a question, you should be able to do it. Okay, not just first you should be able to do it on the pen paper, then you should, if the problem gets really larger, okay, then you can use computers to do this. Okay, I rest my case for the rest algorithms here. I actually gave you the why part also, and I also gave you the roadmap that we're going to follow in next couple of months. And now we will open the floor for the questions, and I would love to hear from you guys.